And welcome to the pre-launch news conference for the Double Asteroid Redirection Test, otherwise known as DART. I'm Daryl Nail, and this is a big deal for NASA. This is the first time that this agency is going to intentionally crash a spacecraft into an asteroid for a planetary defense mission. And if intentionally crashing that spacecraft into the asteroid changes its course, then we will have had a successful mission. Now, it's also important to note we've got some guests here. We're going to discuss all the details about this mission, and they're going to be taking questions from the press. One important note, DART's target asteroid is not a threat to Earth. So DART is scheduled to launch no earlier than 1:20 a.m. Eastern Standard Time on Wednesday, and then at 10:20 p.m. Pacific Time on Tuesday on a SpaceX Falcon 9 rocket from Vandenberg Space Force Base here in California. Now, we got great guests that I mentioned, so let's take a look at them and introduce them right now. We have on our left Thomas Zurbuchen, Associate Administrator for NASA's Science Mission Directorate at NASA headquarters. We have Lindley Johnson, Planetary Defense Officer for NASA's Planetary Defense Coordination Office, also at NASA headquarters, and Ed Reynolds, DART Project Manager at Johns Hopkins Applied Physics Laboratory. Omar Baez is here, the Senior Launch Director for Launch Services Program at NASA's Kennedy Space Center in Florida, and Julianna Scheiman, Director for Civil Satellite Missions at SpaceX. And last but not least, Captain Max Rush, Weather Officer for Space Launch Delta 30 here at the Vandenberg Space Force Base. Now, we'll take your questions in a moment. Just call them in on the phone bridge. But let's get started right now with an opening statement from Dr. Z.
Well, I'm so excited to be here today and, to be part of that first-of-a-kind experiment that we're going to embark on tomorrow, which is, of course, that first test of planetary defense. It's an intentional crash of a spacecraft into a rock. And, of course, what we're trying to learn is how to deflect a threat that would come in. Now, rest assured that rock right now is not a threat, and it will not be a threat before or after. Frankly, of all the near-Earth objects that we know today, none of them is a threat within 100 years or so. Now, the only caveat I need to tell you that we only know 40% of all the objects or so of the size that we're going to get in. I think of it like a football stadium size kind of asteroid, 140 meters or so. We only know 40% of those, 60%, the majority, we yet have to find. Now, when we think about asteroids, of course, we think not just about threats, we think about amazing science. And I want to remind everybody of the decade of asteroids we're in right now. As we speak, a spacecraft is on the way back from deep space with a precious sample that it took during a touch-and-go event last year. The OSIRIS-REx spacecraft took a sample from asteroid Bennu, kind of a real gravel pit that it orbited and found this sample from. It's on the way back, and it will come here in September of 23. We just launched a few weeks ago the Lucy spacecraft, and it's on its journey to go examine the Trojans for the first time. These objects at about Jupiter distance, of course, tell us about the history of the solar system, and we've never visited them. And Psyche is a mission that's going to launch in less than a year to what we believe may be a failed planet, a metal world of sorts. Of course, we don't know. That's why we go there to go investigate. We even have the Janus mission, kind of two little spacecraft as a secondary payload, also looking at double asteroid systems flying with Psyche. So the science is just absolutely compelling, learning about our own history, the history of the solar system. And it's really critical that we do this. Now I want to tell you, this planetary defense, together with our Earth science climate type of work and the space weather work, really focuses on places in which science can really help humanity. It can help protect and improve life here. Again, observing the Earth with the 20-plus spacecraft that are there, 10 more to launch in the next year or so. Frankly, helps us understand hazards that are here on Earth. Similar can be said about space weather. And I'm really excited about this planetary defense portfolio, the first mission of which is DART, to do just the same. Whenever we have a global challenge, like each one of the challenge we are talking about, we also need a global response. And we're doing that, of course, in climate science and space weather. We're doing it here also. And what I really want to stress is how indebted we are to the work of many partners. At the forefront, right there, of course, is the Applied Physics Lab, that has done an amazing job. Doing a mission like this is already hard without a pandemic. Doing it during a pandemic makes that hard mission something that takes everybody in the team to their fullest. And that's why we're here today. Of course, SpaceX did the very same thing. And I also want to recognize that the Italian Space Agency, OSI, provided the CubeSat that is going to image that collision from nearby. Thanks to them also. Finally, the European Space Agency is working on a mission, the Hera mission, that will go check up on that collision that we're doing, and that European Space Agency will go in the mid-20s and investigate the why. Why was the response to that collision the way it was? So again, it takes many to do something as important as planetary defense. And that's the right time to kick it over to the person on the left. Before I do so, I want to just quickly point to the picture here. And the picture, of course, is the Systems Mission Assurance Manager, Alexei Hoyle, standing in front of the fairing as it gets encapsulated. First of all, you see the spacecraft easily fit into that fairing. SpaceX didn't give us a discount because of the extra space, I'm told. But look, together with Alexei and every one of our gratitude, our appreciation goes to the entire team that made this mission, made this launch vehicle a reality. Sorry, the Master Defender here, Lindley Johnson, the Director of the Planetary Defense Office. Why don't you take it away?
Okay, thank you, Dr. Z. Yeah, the last look at DART there before it begins its journey. It's a small but mighty spacecraft. I also want to thank SpaceX and the team for, as we saw earlier today, a very clean and proven launch vehicle. Looks like they're going to be able to give us a good flight. And also thanks to the many years of hard work from the DART project, managed at APL, but with a number of partners. The DART project is a part of a larger portfolio that we have for the Planetary Defense Program at NASA. If I could bring up that first graphic here, it shows you the 5 sectors that we have worked in planetary defense. First or foremost is we have to find them. We talked a little bit about what we have found, but if we don't find these objects that could be an impact threat to the Earth, a hazard to the Earth, we can't do anything about them. So that's a major part of our program, and we manage several projects across the U.S. and coordinate with our international partners with observatories that search the skies every night that they can to find these asteroids that come near the Earth. There are some, we now have 27,500, a little over 27,500 near-Earth asteroids of all sizes in our catalog. But as Dr. Z said, according to our modeling, that's only about 40% of the population that could be out there of 140 meters and larger. So we still have a ways to go with that. And our next mission, in fact, will be to do that. The NEO Surveyor mission will be a space-based IR telescope specifically designed to find the rest of this population that we're looking for. Then the second sector is once we find these objects, we need to characterize them. We need to know more about their orbits, where they're going, so we can predict when they might be a hazard to the Earth. And what's their size? Are they large enough to make it through Earth's atmosphere, or are they small and they will disintegrate in Earth's atmosphere? Earth's atmosphere does a very good job of protecting us of the everyday hazard that's out there, the meteors that you see every night in the sky, and an occasional larger fireball. So knowing more about the objects to know how big a threat they are is a big part of our program. Then we work, the name of the office is Planetary Defense Coordination Office, so we work with a lot of partners around not only the country but the world on this effort. So planning our strategies, coordinating with them, and if we were to find an impact threat, working out what we would do in response to that. And so our work right now with the DART mission is one possibility of what we might do if we found an asteroid on an impact course with the Earth. So we're testing this kinetic impactor technique where we just ram a spacecraft into the asteroid at high velocity to trim a little bit of speed off of its orbital path, and that changes it into the future. So mitigation, DART is a big part of mitigation. We're looking at other techniques as well. And then we, of course, need to be able to assess our success at doing these kinds of things, and we have efforts to do that. And so this strategy is all guided by a national near-Earth object preparedness strategy and action plan. If I can show the next graphic here, that strategy and action plan has 5 goals. It's a 10-year plan for improving our capabilities, enhancing our capabilities to improve our response to a possible impact threat, and DART is a big part of the 3rd goal there, in testing technologies and techniques that could be used to deflect a hazardous asteroid. And so let's learn more about DART, Ed.
Okay, thank you, Lindley. First of all, I just want to say how excited and proud the Applied Physics Lab is to participate in the DART mission. We think this is important and this is exciting, and we're just really proud to be a part of it. So if I could have slide 1, please. I'd like to talk about just the overall geometry of the mission first, and then I'll talk about the spacecraft. So as you heard from Lindley, our mission is to hit an asteroid at 15,000 miles per hour. That's tough, that's hard. And we've worked really, really hard to design a mission that will hit the moon of an asteroid system. So we have, as you can see in the graphic, you see 2 asteroids, the double asteroid. One is large, about 760 meters across, and the other one is smaller. Our target is the smaller asteroid, and this is key. This is the perfect environment to test this methodology. So that small asteroid orbits the larger asteroid every 11 hours and 55 minutes. When we hit the asteroid, we expect to change the period of that asteroid by about 10 minutes. So it will go from 11 hours 55 minutes to 11 hours 45 minutes. And so with that, we can do a lot of the analysis and that we need to determine the effectiveness of using kinetic impact as a tool, as one of the strategies to protect Earth from asteroid impacts. So in the graphic you see the DART spacecraft. It's in its deployed configuration just right before impact. And so you also see the smaller Leachy cube. And so just a little bit about Leachy cube. We will release it from the larger spacecraft about 10 days before impact, and it will basically image the DART impact before, during, and after impact, and then transmit images back to Earth. Key things to note about this mission is it's short. It's 10 months. So we'll launch tomorrow, and then within 10 months, we'll go from basically stabilizing a spacecraft, get it commissioned, and then we will go through a period of cruise, and during that cruise period we have some other new technologies on board the spacecraft that we will evaluate. I'll talk about that in a second. But then the last 30 days, we really focus on the impact. And so we will ramp up our activity with the spacecraft and basically work on image collection, navigation. And it's really when we get to the last hours of the mission before impact, we will hand over control of the spacecraft from being controlled from Earth to being completely autonomously controlled on the spacecraft. So the last 4 hours are autonomous. We use a technology called SmartNav. It's a series of algorithms that are really refined to hunt down and target the asteroid in the center of the asteroid. And so with that, if you can display slide 2. This is the spacecraft as it just right before, a couple weeks before it went onto the rocket. So as you look at it, it's small. It's smaller than a car. And we're going to impact something as large as 160 meters across. It's almost the size of a football stadium. And so part of the technique is we're going to give the spacecraft a nudge. We're going to hit it hard, but we're hitting it with a very small vehicle. It doesn't take a lot, but when we're looking at what does it take to deflect an asteroid away from Earth, given enough time, you can do big things with small vehicles. And so that's what you're seeing. You're seeing the spacecraft in its launch configurations. We have new technologies like very lightweight solar panels. We have ion thrusters that we will be demonstrating in flight. And then we have things like flat RF antennas that are another new technology. So we're really excited. As Lindley said, or as Dr. Zurbuchen said, we built this during COVID. Right as the beginnings of integrating the spacecraft occurred. That's when the pandemic broke out. We actually had to change how we build spacecraft to work in smaller teams and to avoid people getting contaminating each other, and it worked. It's the team came together and it just worked. And so with that, I'd like to hand over to Omar Baez.
Thanks, Ed. And how cool! We're smashing into an asteroid. What a fall. And I want to thank the folks here as part of the Launch Services Program. It's a pleasure to work with our partners at SpaceX, APL, our customer Science Mission Directorate, and the 45th Space Wing Delta. What a cool fall for us. We started with Landsat in September. Then we did Lucy in October, looking at an asteroid, but long term. We're going to go and look. We're not going to smash. And this one is pretty cool, 10 months, and we're going to rendezvous and hit this and impart some English into it. Fantastic. I can't believe we're doing that. It's unbelievable. So this all started back here at Vandenberg Space Force Base on the 2nd of October with arrival of the spacecraft. If we could roll some video that we have. This is a spacecraft that's been shown before, or our cue ball, and we're going to be imparting some Delta V into that with this Falcon 9 rocket. This was first used for Sentinel-6, the Michael Freilich mission last year, and since it's been used with a commercial mission. So the rocket looks a little bit different with a little bit of patina from the plasma flux coming back in and just a booster. But we're looking forward to it. Last week we did our mission dress rehearsal and prepared the team. We encapsulated the spacecraft within the payload fairing. We did our flight readiness review, which gave us the go to perform our static fire. We successfully completed the static fire this past Friday over the weekend, and today we made the encapsulated assembly with DART inside of it to the Falcon 9 rocket. And today we completed the wing launch readiness review and the NASA launch readiness review, and we're all go. There's no holdbacks. There's no risk to going forward. And we look forward to tomorrow. Tomorrow we're going to show up about 6 hours before launch, start prepping the vehicle. It should be vertical sometime tonight, and the team will show up just before 7, get situated in their consoles, and get ready to load cryogenics inside of an hour from launch. And we only have one opportunity to do this per day, and it's a 1-second instantaneous window. And so we're looking forward to doing this right on time and the first time. And tomorrow's scheduled time for liftoff is 10:21 and 2 seconds. If by chance we have to delay another day, it goes earlier by about a minute. So that's kind of the sequence. So we're looking forward to it. What a phenomenal mission. And I'll turn it over to our partners at SpaceX with Julianna Scheiman.
Thank you, Omar, and thank you to the team. I think I want to echo everybody's sentiments that this is just the coolest mission. So thank you all for enabling SpaceX to be a part of a really important planetary defense mission. Like I said, I'm excited to be here today with the Associate Administrator, with our partners from the Applied Physics Lab, from NASA LSP, but I'm especially excited to be here today with the Weather Officer, who's going to make sure we have great conditions for tomorrow night. So DART is SpaceX's first interplanetary launch for NASA. We've launched a plethora of Earth observation missions, like the Sentinel-6 Michael Freilich mission that was talked about, like Discover. We've launched critical supplies, research, and astronauts to the International Space Station. But this is the first time SpaceX has taken a NASA spacecraft and intentionally launched it on a trajectory to escape Earth and crash into an asteroid. So again, pretty cool mission. Very excited to be a part of it. As Omar mentioned, the DART mission is actually the first flight-proven booster we're flying for the NASA Launch Services program. The DART booster previously flew on the Sentinel-6 Michael Freilich mission and a Starlink mission. I think we actually have a photo of the Sentinel-6 launch and landing. Yeah, thank you. So you have a sense of what launch and landing looks like. It'll be a little bit different for the DART mission. For DART, we'll be landing the first stage out at sea in the Pacific Ocean on the drone ship, Of Course I Still Love You. So a little bit about the rocket today. You heard about that a little bit from Omar, but last week we completed a successful full-duration static fire test. And as Omar said, everything on the rocket's looking great for our launch attempt tomorrow. The team's planning to roll out this evening, and we're not tracking any issues. So looking forward to our launch attempt tomorrow night. This mission is our 4th mission for the NASA Launch Services program, and actually in a few short weeks we're launching IXBI, also for the Science Mission Directorate. And IXBI will be our 5th launch for the NASA Launch Services program. That will launch out of Florida, out of Kennedy Space Center. So on behalf of everybody at SpaceX, we are so proud to be part of this really cool planetary defense mission and to do our part to contribute. So thank you all for being here today. Go ahead.
Thank you. All right, so talking about the weather for the launch tomorrow, looking at November as a whole, late November, it is quite active and more prone to fronts and than more than the rest of the year. Fronts, strong winds, and thunderstorms. We do currently have a front approaching us, but it happens to align where it is favorable for the launch, so that's really nice for us. If we could go to that satellite shot, we do currently have the front approaching. It is very distinct off the coast there as it heads towards the west coast. It is fairly far north, and we can be confident that we're not going to get hit by the brunt of it, which is nice. We're just going to get hit by the tail end of it. Also, as it comes onto land and down the coastline there, it's going to be broken up or split by the coastal ridgeline. This is going to weaken it and allow it to settle a little bit by the time it gets to Vandenberg. Moving on to the day of launch forecasts. We have, for primary day, we will see some impacts of the dampened front as it just passes a few hours before the launch. And the cold front will temporarily usually wipes out the marine layer, but the front is still a little bit close, and we could see some visibility constraints, or basically some visibility, reduced down to about 1 to 3 statute miles. Actually, so the concern is normally surface winds, but it is actually 10%, not 90% there. So we're looking at around 18 miles per hour with temperatures around 52 degrees. And that 90% there is 90% that it will go. As we said before, we're going to see some elevated winds, and for backup day, it's going to be even better. So we're looking at 100% chance. There's no concerns for us, no surface wind constraint that we're looking at. We got 5 to 9 miles per hour from the north-northwest, and temperatures around 54 degrees. And that's all for weather. I hope that we have good viewing for the launch, really. That's what we're all hoping for. So yeah, that's all I have, and thanks,
I was
Darryl.
hanging on to what you were saying about that cold front pushing out the marine layer. Let's hope so, because Vandenberg is known for its marine layer.